Alright, this is 2.2b in elementary algebra, and that blue is a little too dark, so I'm going to change that. Okay, so let's go to example number 6 here. Example 6 says if we have 7.3 plus x equals negative 2.4. Boy, they sure jumped to more of a challenging problem, didn't they? But one of the key things, again, is there's my x. That's what I'm trying to isolate or get by itself. I need it on one side of the equal sign all alone. Well, there's a 7.3 being added to that, so we need to get rid of that. So because the 7.3 is being added, we need to take it away. So one of the things that a lot of students do, and you can kind of do what you want with it. In the last one I was writing 7.3 minus 7.3 and rewriting the whole thing. But one of the things that you can do is just underneath it write minus 7.3. Positive 7.3 minus 7.3 is 0, so that will go away. But if you subtracted it from one side, you subtract it from the others. And now I have x equals negative 2.4 minus 7.3. Now, remember what we've done. You make that a plus, and you make that a negative, and you put it in parentheses. And then you look and say the biggest number, right here, is 7.3, and it's negative, so my answer is going to be negative. And I have two negatives, so the signs are the same, so that means I add them. And I get 9.7 for my answer. Alright, so let's go to example number, 7. Alright, 7 says we have negative x plus 2 plus 2x equals 7 plus 5. Alright, so what happens here is most of the time there is stuff you can do on this side of the equal sign and stuff to do on this side of the equal sign before you worry about getting x by itself. Okay, so we're simplifying the left-hand side and the right-hand side before we even do anything. So let's see if we can simplify the left-hand side. First of all, we have a negative x and a 2x. These are like terms, so we can put those together. So let's go ahead and move that 2x over so it's next to the x. Didn't really do anything here except 7 plus 5 I can just write as 12. Okay, so let's combine these two. The largest x is the 2x, and it's positive, so I know when I add those two, the negative x and the 2x, I'm going to get a positive answer. Signs are different, so I take the difference between the two. Okay, now I'm going to get rid of this positive 2. Well, it's a positive, so I'm going to subtract it from both sides, and I end up with x because I can take away that. This goes away, and this equals 10. Okay, so 12 minus 2, or 12 plus negative 2, is going to give me that 10 there. Alright, let's jump up to example 8. And again, these are just getting more and more challenging as we go, but they're not too bad. And this is what you're going to find most of the time, is you're going to be able to simplify each side of the equation before you try to get the variable, in this case an a, by itself. Alright, so PEMDAS says you're doing the parentheses, so we're going to distribute. Okay, that times that, that times that. 2 minus 3 is 2 plus negative 3. Answer, the biggest number is negative, so that will be the answer, and the signs are different, so we take the difference. Alright, so let's combine this with this. So 8 minus 7 is 1. Okay, so I simplified the left side, simplified the right. Now I'm going to try to find my a. And the way I find my a is I get rid of everything else except the a. So that's a negative 12, so to get rid of that I add its opposite. That goes away. Negative 1 plus 12. 12 is the bigger number, it's positive, the signs are different, so I take the difference between 1 and 12 and get 11. Which, as I look back into the book, they got 9, and the reason for that is I wrote the problem down wrong, and that 3 is supposed to be a 5. It should be 2 minus 5, but for this problem that I did, 11 is the correct answer. So that's one of the things that even after teaching this for a bazillion years, you still make numerical errors. So just something to be cautious of. And fortunately for me, I can just apologize for it. When you do this on a test and you make that mistake, you're just kind of stuck with the wrong answer, aren't you? Alright, so 3x minus 5 equals... Alright, notice the problem here. We have an x here and an x here. Alright, we can't have an x on both sides of the equal sign. We have to get the x's all on one side. Now it doesn't matter if I move this 3x over here with this one or this one over here with this one. But the fact remains it has to go. It has to go over somewhere. Now I usually like to move this one over here just because I'm used to having the x on the left side. But more importantly, if you have a 3x here and a 2x here, you usually try to move the smaller x over. The number in front of the x that's smallest, you usually try to move over because that keeps you from getting negative answers usually. But it doesn't really matter, you kind of do what you want. So first of all, let's move the x over here so that we have all the x's on the left hand side. Well, this is a positive 2x. So to get rid of it, I subtract it. I do its opposite. Okay, so 2x minus 2x is 0. 3x minus 2x is 1x, and that's still 1 minus 5 equals 7. Okay, so the x is still not by itself. We still have this minus 5 there. So what's the opposite of 5, or minus 5? Positive 5. So now we have x, two opposites that are the same number, cancel out. 7 plus 5 is 12, and we're done. Okay, let's try a couple examples from the homework, and then I'll turn you loose. So I'm going to assume that you're not going to have too much problem with 1 through 28, and I'm going to jump into 29 to 69 just so you have a little bit more practice. So let's do number 32. That's got some stinking fractions in it. Might be nice to kind of, if you can do the one with the fraction, you can do anything. So let me write this down. Alright, so let's look and see if we can combine anything on the left side and then on the right side. I can combine these two because those are like terms. So 9a minus 8a is 1a. Just kind of leaving the 1 off of there, doesn't matter. Okay, let's look at this side. Those are just two numbers. They don't have common denominators, so if we give them common denominators, life is good. But, well, wait a minute. Look at this. Eventually, we're going to be moving this to the other side, right? We're going to have to add 4/5 to this side. We're going to do the opposite to get the a by itself, which means we're going to have a 4/5 over here that we're going to add. So why don't we do that first, and then I can add it to this 1/5 before I mess with 3/10 minus whatever this is. Because if I find common denominators now, I'm going to have to do it over again when I move this over, if that makes any sense. So let's add 4/5 and 4/5. So I have a equals, because those will go away, 3/10 negative 1/5 plus 4/5. The biggest number, 4/5, is positive. The signs are different, so I'm going to take the difference between the 3 or the 1 and the 4. when you look at a fraction, when you're looking at subtracting here, you're just taking the difference between the top number and the bottom number. Now when we've done like 3 minus or plus -5, what you've done is you take the difference between the 3 and the 5 because the signs are different. If you made those into fractions, what would you do? You do the same thing. So when you take the difference between the two, it's basically the numerator, the top number of any fraction. So that's why I took the difference between the 1 and the 4, is because those are the numerators. Now I can find common denominators. So 3/10 common denominator is 10. What did I do to the 5 to get it to be a 10? I multiplied it by 2. So I multiply the top number by 2. So now I get A equals 3/10 plus 6/10 is 9/10. Okay? So let's keep going here. We're going to jump all the way to number 52. And notice instead of an X, they're using an M, which is okay, doesn't really matter. Alright, so we're going to distribute first. We're doing the parenthesis thing here first. And I'm not going to explain every little bit of stuff I do here, but I'm just distributing. 15 minus 8 then is 7. Now I'm going to see if I can combine anything here on the left side. Do I have any like terms? I do. Those are like terms, and plus 15 and plus 2, those don't have any letters, so those are like terms. So negative 5m plus 6m. Largest number is positive. They're different signs, so difference between the two. And 15 plus 2 is 17. Alright, again I'm trying to isolate or get the m by itself, so I'm going to do the opposite to both sides to get rid of those. And I have m equals negative 10. Okay, let's see if I have time for 2 more here. Alright, again I've got an m and an m, but they're on opposite sides. So remember in one of the examples I said let's get the smaller number over with the bigger number. So to get rid of that I do the opposite to both sides. 8 minus 7 is 1m minus 1 equals, those go away, negative 3. Don't forget to put that minus sign there. Alright, now I do the opposite again. And I get m equals, sign of the largest is negative, the signs are different, I take the difference and I get negative 2. Okay, this one has fractions, but we're going to do the same thing. We're going to get the x's on the same side by getting the smaller one and doing the opposite. 3 minus 2 is 1x minus 5/4, and that goes away, equals 1/4. Alright, so now we're going to add the opposite to get the x by itself. Those go away, and we get x equals 1/4 plus 5/4. And remember, adding fractions, you add just the numerator there, and 6/4 can reduce because 2 goes into 3, or 2 goes into 6, and 2 goes into 4 3 times. And that ends up being your answer for number, oh gosh, which one was that? 66. Okay, so anyway, that's it for lesson 2.2.